So now we're going to look at creating a graph for our equation. We're calling this graphing a linear equation because when we graph the equation, it's going to make a straight line. So the example we're going to do is y equals 2x plus 3. And we're going to start by making a table with our x and y values and our ordered pairs, which tell us which coordinates we're going to graph on the graph. So if they don't give you x values, you get to pick your own. And I would pick easy numbers, friendly numbers like 0, 1, 2, 3. You can pick any numbers you want, but you might as well make it easy for yourself. So in this example, I'm going to use 0, 1, 2, and 3. So x is my input. I'm going to input the x, the 0 for the x. So when I do that, I get 2 times 0 is 0, plus 3 is 3. So my ordered pair is 0, 3. Now I'm going to input the 1. 2 times 1 is 2, plus 3 is 5. So now my ordered pair is 1, 5. Now I'm going to input the 2. 2 times 2 is 4, plus 3 is 7. So my ordered pair is 2, 7. And last I put in 3. 2 times 3 is 6, and 6 plus 3 is 9. So my last ordered pair is 3, 9. So now that I have my table of values, I'm ready to start putting them on the coordinate plane. Remember, the x-axis is the one that goes across or horizontal, and the y-axis is the up and down or vertical. I need to put some numbers along my axis, so I look at my x values. 0 is my lowest, 3 is my highest, so I can count by ones. I have plenty of space. Now for the y, I look and my lowest is 3, my highest is 9, so I think I have room I can count by ones here as well. Now some of you may be looking at that and go, but you counted by 2s. Well, the numbers are going by 2s because I was just a little lazy. But you can see this line is 1, this line would be 2, this line would be 3, this line would be 4. So I'm still counting one space for each line. I'm just not writing all the numbers in. Okay, so now I take the first ordered pair, 0, 3. I start at the origin, I go over 0, and I go up 3, and I make a point. Now I take 1, 5, go to the origin over 1, up 5, make a point. Go to the origin, go over 2, up 7, make a point. Back to the origin, go over 3, and up 9. And there is my last point, and now I connect them. So get a nice straight edge or ruler, so you get a nice neat line. And there is the graph of y equals 2x plus 3. We put arrows on the end to show that the line continues in either direction forever and ever. I could keep going with this if I wanted to. And every point that is on this line is a solution to y equals 2x plus 3, even the ones that aren't. Now, a good graph would have labels for your x and y axis and a title, but we only had an equation here. We didn't have any story. We don't really know what x and y are. So let's look at one example now that has a story that goes with it. All right, this says, Maya's muffins are sold in packs of 4 muffins. Let P be the number of packs of muffins sold and M be the total number of muffins sold. The equation M equals 4P, muffins equals 4 times the packs, represents this situation. Graph the equation. So first, let's make a little table, and let's pick some easy values for P, like 0 and 1 and 2. So if I input a 0, 0 times 4 is 0. If I input a 1, 1 times 4 is 4. And if I input a 2, 2 times 4 is 8. Now I can pick any of these ordered pairs to put on my graph. 0, 0 is easy, so I could put that right here at 0, 0. And then I have 1 and 4. So I go over 1, up 4. And you can see now my line is already made for me in this example, because really any 2 points define a line. But check it out. If we went to 2, over 2, up 8, yes, that point is on the graph as well. And if we look at this graph, we can see it says the Y is telling us the total muffins sold. Let me scroll down a little bit. You can see the x-axis is our packs of muffins. So we have the labels for our x and y axis. Our numbers are evenly spaced. And we have a title for our graph. So this is a great example on how to graph a linear equation.